Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. Today, we're on lesson 14, which is all about fractions. So let's talk about fractions a little bit. The lesson is about expanding and reducing fractions, but first, let's remember what a fraction is. So when we're talking about a fraction, we need to know our vocabulary for a fraction. The top part of a fraction is called the numerator. The line right here is called the fraction line, and the number in the bottom is called the denominator. So we always have to know our correct terminology: numerator, fraction line, denominator. And a fraction is a part of a whole. So I will normally see in a book or on a page part of the figure shaded. So here I'm going to shade 1 out of 2 parts. So the whole is divided into 2 equal parts. That is what the denominator tells us. The denominator tells us that we're talking about 1 out of 2 parts that make a whole. So 1 out of 2 is 1/2, and we have shaded 1/2 of the circle. So over here we have 4 equal parts. So on the bottom, our denominator will be fourths. Okay, so if I'm going to just talk about one of those fourths, then the fraction that represents will be 1/4. If I wanted to talk about 2 of those fourths, then I would need to shade another one. Now, we can see that in a perfect world, with my 2 circles being equal, which they're really not, you can see that this one looks like it's a little bit more like an egg shape and a little bit bigger maybe. But pretend they are the same size circle. Then wouldn't 1/2 of the circle and 2/4 of the circle be the same amount? Okay, so 1/2 and 2/4 are what we call equivalent fractions. They don't look the same, but they wind up being the same amount of the whole. So they are equivalent fractions, and now we're going to be talking a lot about how to change one fraction into another fraction that is equivalent. Okay, let's talk about something that your book calls the denominator-numerator rule. That's a really big name for a very simple rule. What the rule basically says is that we can multiply or divide any fraction on both the numerator and denominator by the same number. So I could take 2/3 and I could multiply the top by 5 and the bottom by 5. As long as I multiply both the top and the bottom of the fraction by 5, didn't I really just multiply by 1? Okay, 5 over 5 is 1. 100 divided by 100 is 1. Any number divided by itself is 1. So let's think about this. Instead of calling this the numerator-denominator rule, we might want to just say this is the multiply by 1 or divide by 1 rule, because that's really all we're doing. As long as we multiply both the numerator and denominator by the same number, we will come up with an equivalent fraction to the original fraction. Another thing that your book is doing that's kind of gone out of date is it's talking about expanding and reducing fractions. Would you agree that 2/3 we multiplied by 1, so isn't this value still 2/3? Okay, so because the value has not changed, most textbooks no longer call this reducing a fraction. They will call it simplifying a fraction, getting a fraction down to its lowest terms. In other words, what is the smallest pair of numbers that can represent the numerator and denominator accurately? But if I took a pizza and divided it into 15 equal parts and I ate 10 of them, boy, I'd be fat, right? But if I ate 10 of them, it would be the same thing as eating 2/3 of the pizza. So the value or the amount of your fraction is not changing at all. It's simply the form. And so I want you to think of this denominator-numerator rule as multiplying by 1 in any form or dividing by 1 in any form. So I can multiply by any form of 1, but I can never multiply by 0 over 0. Number 1, that's not 1. And I can never divide by 0 over 0 because that's not 1. So example 14:1 says expand fraction 3/4 so that the denominator is now 24. I'm going to go ahead and not call it expand. I'm not going to say expand and reduce. I'm going to say let's re-express or find an equivalent fraction. So equivalent fractions is a term that's used over and over in textbooks today. So these books were written a while back and they're still very good, but there's a few terms that need to be corrected. So we're going to correct this one simply because most of your textbooks today will not say expand and reduce. They will say simplify, put in lowest terms. They will say find an equivalent fraction, but they will not use the words expand and reduce when it comes to fractions. Okay, so we're going to try to do what most textbooks would do here. So I'm going to write it in this form. We are going to find an equivalent fraction to 3/4 that has a 24 on the bottom. Now we're going to do this by using that numerator denominator rule. And there's nothing wrong with the rule name, it's just very cumbersome. Numerator denominator, it's a lot of syllables, right? But we're simply going to multiply by 1 in a form that's going to get the 4 to a 24. So we know that 4 times 6 is 24. So I'm going to multiply by 1 in the form of 6 over 6, which is going to give me 18/24. And 18/24, when I simplify it, will become 3/4. They are equivalent fractions, but this one has the desired denominator on the bottom. Okay, so then it says write each number with a denominator of 20. So the first number is write a 5 with a denominator of a 20. Well, the first thing I'm going to do is I'm going to remember that 5 is the same thing as 5 over 1. Okay, so I'm going to multiply by a form of 1. Oops, that should have been my time sign there, right? To get a 20 on the bottom, well, 1 times 20 is 20. So I'm going to multiply by 1 in the form of 20 over 20. Always multiplying or dividing by 1. Okay? Because when I multiply by 1 or divide by 1, I do not change the value of the number. So now I've got 1 times 20 is 20, so that works. 5 times 20 is 100. So 100 over 20 is the same value as 5, but now I have the desired denominator. Okay, so I did just a little adjustment. This had said reduce 30 over 45 to lowest terms. Lowest terms is a very good term, so this does not need to be changed, but we'll change reduce to simplify because we want to change the concept that the fraction is in any way getting smaller. Okay, it's staying the same quantity, it's just getting a different name. All right, so what we want to do is we want to get the smallest numbers in the numerator and denominator that will still equal 30 over 45. Okay, so we're looking for a common factor in 30 and 45. And we could pick 5, but that's not the biggest number that both 30 and 45 are divisible by. 30 and 45 are both divisible by 15. So I'm going to put divide by 15 and on the bottom divide by 15. Now 15 over 15 is just 1, so I'm basically dividing the numerator by 15, the denominator by 15. 15 over 15 is 1, so I'm dividing the whole fraction by 1, which changes nothing. So 30 divided by 15 is 2, 45 divided by 15 is exactly 3, and my simplified lowest terms fraction is 2/3. This is your practice. We're already on your practice. This was a nice short lesson. Okay, so they're telling us in the first part, the A part of the practice, it says write each number with a denominator of 18. So 3 with a denominator of 18, 1/6 with a denominator of 18, and 4/9 with a denominator of 18. So here I'm going to extend this to have the 1 underneath. So 3 divided by 1 is the same thing as 3. So I gave myself a denominator just so it would be a little bit easier to figure it out. So now I'm going to multiply. I'm trying to get to an equivalent fraction that has 18 in the denominator. So won't I multiply by 18 over 18, which is 1, and does not change the value, but now 1 times 18 is 18, so that's a check mark, right? And 3 times 18 is going to be 3 times 8 is 24, carry the 2, 54. Okay, so 54/18 will simplify to 3. And we did what they asked us to do. 54/18 is the equivalent fraction that has 18 in the denominator. Okay, so this one is 1/6, and we're to turn the denominator into an 18, but keep the equivalent fraction. So since I need to multiply by 3 on the bottom to get 18, I will also multiply by 3 on the top. So 1 times 3 is 3, and 6 times 3 is 18. So 3 over 18 is the same fraction part as 1 over 6. And if we were to draw a pizza and we were to have it cut in 18 pieces and we ate 3 of them, it would be the same thing as having it cut in 6 equal pieces and eating 1. Okay, so here we have 4/9, and we need an equivalent fraction that has an 18 on the denominator. 9 goes evenly into 18 2 times, so I will multiply by 2 over 2. 4 times 2 is 8. 9 times 2 is 18. So the answer is 8 over 18. And now we go to the B part of our practice. Now we have 3 fractions that we are to simplify to lowest terms. Your book says reduce, but we're going to simplify because the final result will be an equivalent fraction that is the same value as the one we start out with, but we will be simplifying to lowest terms, so we will get the numbers down as small as we possibly can and still maintain the same value. Okay, so 18 and 24 are both divisible by what number? Okay, when you think about their common factors, aren't 18 and 24 both divisible by 6? Okay, so we're going to divide by 6 and divide by 6. Same thing on the top and the bottom, and then 18 divided by 6 is a 3, and 24 divided by 6 is a 4, and my simplified fraction that is equivalent to 18 over 24 is 3/4. That's all there is to it. Okay, so let's look here. What factor does 36 and 72 have in common? Well, 36 is exactly half of 72, and 72 is double 36. So can't I divide by 36, divide by 36, and 36 divided by 36 is 1, 72 divided by 36 is exactly 2, and we have a fraction in lowest terms of 1/2. Okay, and the last one on this section, we have 15 and 25, which are both divisible by 5. So we're going to divide that one by 5 and divide this one by 5. Numerator by 5, denominator by 5, always the same number because 5 over 5 is 1. So 15 divided by 5 is 3. 25 divided by 5 is 5. 3 divided by 5 is 3/5, and 3/5 of a pizza is the same amount as 15 25ths of a pizza. And we are done. And this is Mrs. A, and may God bless your day.